So now we can practice computing determinants using a couple of different row expansions. So the task here is to compute the determinant of this matrix. Notice the notation here. We use these vertical bars, like absolute value bars, to denote the determinant of a matrix. So first, if we expand along row 1, so we're going to expand along this row here. Make sure that when we do this cofactor expansion, we need to apply these alternating signs. So it always starts with a positive in the upper left-hand corner, and then alternates from there, whether down a row or across a column. So I've placed these alternating signs here just as a reminder. Now I'm going to write out the expansion. So we would start with positive 1, so I'll just write 1, times the determinant of the 2 by 2 matrix when we delete this row and this column. When we delete the row and the column that this 1 belongs to. So we delete row 1, we delete column 1, and we're left with this 2 by 2 matrix. So 4, -1, -2, 0. Okay, and then I'm going to move along down the row. So now next entry. Don't forget the sign here. So there's a negative applied here. So we're going to do -5 minus 5 times the determinant of another 2 by 2 matrix. Now we would delete, again, the row and the column that 5 belongs to. So when we do that, we're left with this 2 by 2 matrix, 2, -1, 0, 0. And we delete the row and the column that the 5 belongs to. So 2, -1, 0, 0. And then now continue to move down the row. So positive or plus 0 times the determinant of a 2 by 2 matrix. Now at this point, I wouldn't even bother finding this submatrix here. It doesn't matter, because whatever it is, we're going to multiply that determinant times 0. So this last bit here is going to be 0 no matter what. Just for the practice, though, I'll delete the row and the column that 0 belongs to. So if we really wanted to write the submatrix for some reason, that submatrix will be 2, 4, 0, -2. So I'm going to write that just for completeness, but you wouldn't need to find that if you're working this problem. So now once you're down to a determinant of a 2 by 2 matrix, you can do this sort of cross-multiplying thing where we say, okay, this is 1 times, so here I would do 4 times 0 minus -1 times -2. That red might be a little hard to read, sorry about that. And then minus 5 times the determinant here, which would be 2 times 0, 2 times 0, minus -1 times 0. Well, okay, so let's just stop beating around the bush. That's just going to be 0. And then 0 times this determinant, but who cares at this point? We know we're multiplying by 0, so that's going to be 0 there. So this right here is 1 times, this will be 0. This product here is 2, so 0 minus 2. We get -2 in here. Minus 5 times 0 minus 0, well, so that's 0, plus 0. So overall, we're going to have -2 minus 0 plus 0. So -2 for the determinant. Now, we should get the same answer no matter which row or column we expand along. So in the instructions, I'm asking you in this example to expand now along row 3. Again, we should get the same result. Begin by noting your alternating signs. So starting with a positive in the top left corner and alternating from there. So this will be a positive down here. So along this row, it's going to be plus, minus, plus. That's our alternating signs that we need to apply. Now writing out this expansion, we'll have 0 times the determinant of a 2 by 2 matrix when you delete the row and the column that 0 belongs to. Since it's 0, we don't even need to mess with the submatrix, but again, just for the practice, I'll write it out. So it'd be 0 times the submatrix for that entry would be 5, 0, 4, -1. And then we have minus -2, so minus negative 2. It'd probably be a good idea to just call that plus 2. But I'm showing all my steps here. Delete the row and the column that negative 2 belongs to, and so we have this submatrix. 1, 2, 0, negative 1. And then plus 0 times, well, who cares? So at this point, let's start getting in the habit of we're doing an expansion, you run into a 0, you don't need to mess with the submatrix for that because it's going to be whatever it is times 0. So same thing here, 0 times who cares, this is going to be 0, plus 2 times this determinant, which would be 1 times negative 1 minus 0 times 2 plus 0. And so this will be negative 1 minus 0, so negative 1. So we end up with 2 times negative 1, so negative 2 for the final answer. You should get the same value no matter which row or column you expand along, like we see in this example here.